Sounds good.
I've been really diving into buffalo butter lately. I received a shrimp with garlic and herbs, and I served everything. For dessert, I made baked peaches with honey ice cream and candy pecans, and that was it. Okay, superstar. Today's safety, so decided that this is going to be my last week. So decided to switch over to cigarettes pretty soon. Realized a lot of you got
Everybody ready? Should we just start? Oh. You're late. Yes, I'm late. Okay, hello, my name is Eric Schwell. This is issue Airman. We're going to take you through some open source edge success at scale. Issue if you would be my clicker. What we're going to do today, we're going to show you a little bit of backstory about how we, in the last 4 years, put together this architectural project at Red Hat, bringing to you inside views of what is going on with customers at scale in various use cases for architectural topics. Right. So, this is a little bit of a background of why this became an issue and what we're kind of looking at. We've all been in IT for a while. How many people started as developers here? Have a little bit. Anybody here build a house or remodeled a house? We've all run into architecture, right? It looks really pretty. Have these really specific lines when you're designing software, a car, or a house, or a bathroom. It doesn't really matter. Everybody thinks when they design these things, this isn't going to come out exactly. I measured it to the centimeter or to the inch. What I'm going to do, right? This is very easy. Just hand it to somebody and build it. But what you end up getting is different interpretations, and I know this is really crazy. Think about this, someone built this, somebody did this, somewhere in the world, I don't know why. I'm not pointing fingers. No, but I mean, it's just crazy, right? You're like, how did you get this out of that? Whatever. I mean, how many people have done software architecture? I've done functional designs that I hand off a sub part of a project to somebody. I'm like, how can you mess this up? Friday they come back with something I didn't ask for. Who hasn't seen that? You know what I mean? So what we'd like to do is we'd like to take people that have done things really, really well and be able to expose you to them so that we can all build stuff like this. If you map this out correctly, or at least give you some kind of insight, because we're all smart enough, we've been around a while, we know how to build what we're doing, we think we're in a company for long enough that we're able to come up with some kind of architectural designs and plans. But we're just looking for the hints, the tips, and the tricks from people that have gone ahead of us. Tie this together at scale. It's just a big problem with how can we get this stuff to scale? So what we did is we stepped back and we thought there's several problems in this space when you're in an organization trying to share public references. Really hard to get along with living public references that tend to go back. Often it's a very light, fluffy insights that just do something. Really detailed stuff that we do when we go into a customer, we create a repository, all kinds of stuff. Those are the things that we're interested in. That's sort of an information flood that you don't really want to have to dig through yourself either. What we decided to do was to step back, do customer research. 2 to 3 is the ideal. Pick a certain use case or a topic. We can sit down and try to find 3 of these repositories that are open enough and contain enough information that I can look at them. But I do not want to map exactly what they did. It doesn't do you good either. What I want to do is find the common similarities in what they're doing. Narrowify that, present that in a form that's edible for us to do something in our own. So, came up with a diagram tool. You're going to see a slide on the one. There's going to be 3 different levels of diagramming plus architecture. Architecture came later, so nothing to do with the diagram tooling. It's just how do I talk to people that have no understanding of the technical side. The stories that we put together behind this are so interesting that the higher level people would like to see too. So, okay, architecture, anybody can see that. We do some enablement presentations around it, so we tied together a short public-facing story. What's going on in this architecture? Record that, so you can publicly and see how to talk to it. And the original targets were our solution architects in the field helping customers, often looking for something like this. Okay, my customer would like to talk to somebody. Well, that's hard to find. So how about this? This is as close as I can get you to. That's kind of the plan. Sometimes we do solution briefs where we, together with the publications, or I write an article down through the list of use cases, diagrams, present that in an article format. I can do that. Solution brief is just a type form of that, so you get like a 1 or 2 page. If we have any internal facing demos, we'll tie those in, but you can imagine these use cases are rather broad. Automated development, delivery of software. So one demo is kind of hard to feed into that. You'll see stuff attached like that. Outside the architecture, which is plenty of examples with, because we're going to feed into architectures each one of these. See on the left there a logical view, and first thing you notice, this doesn't look like sequence diagrams, UML, TOGAF, if you're all excited about it. That is just a flood of information that requires an understanding on my side of what I'm designing and on your side of what I'm doing. It's very complex, very good. These things we decided to step back and say, hey, let's take 3, 4 colors, choose some branded icons, and some templated size and setups, right? Logically group what I found in this article. Really simple. Talk to anybody. You can complicate the story or simplify the story depending on who you're telling it to. She's going to demonstrate. These are much more specific. This is a schematic or physical diagram. This is pretty much what we look at from like ingesting something on the front side. Get lucky like this. I actually numbered this one because it has to do with deploying across the cloud data platform. So it looks like our application goes on development test. That's a really fun one where you can easily flow. So, say I want to zoom down in on this thing. That's what this is. You might pop it up. So imagine you're talking to some audience or something. You really want to zoom down in on integrated microservices. Pop it up. Talk in detail what's happening in that specific space. Again, very high level stuff. Who I talk to, what talks to me, that kind of thing. Not trying to force you into my way of doing things, it's telling you how people are doing this shit. So where you can find this. That. You can start taking through a few of these use cases.
So I talked about architecture. These are examples of edge use cases, how you use the same Can you guys hear me? So we're going to be talking about edge use cases. There are a number of them. Edge. And within the same group. So let's jump into it. Before we kind of get into this, I want to make sure that we are setting the expectations on why people are moving to it. We hear a lot about edge computing, stage 4, a lot of industries are moving to it. What's driving them is some of the challenges they have with central computing. So, this is shift from our computing started right? Mainframe, then computer, then it was client server, and then it moved to centralized computing, where all the hyperscalers come in and computing is located at central location. And this is another iteration where people feel that now there is kind of data going from edge side, especially if you're talking about something really off in a oil and gas rig in the ocean somewhere, or a windmill hanging off somewhere. The connections are off cellular, or they're going to be connected to the latency, or even like autonomous vehicles. Like you talk about instant decision making when you're driving a car, and the driver assist feature that cannot wait for the latency of sending the data back. Bandwidth, we're talking about a lot of data being generated on the edge. God and I talked yesterday about aircraft engines being monitored. I mean, engine can generate almost a terabyte of data in a single file. Same thing with locomotive. The train engine can generate data on and off, right? So all this data cannot be sent to the centralized side. We need some way of seeing what's important, what's not important, doing some processing on the edge, and then taking some set of data. So these are some of the things why centralized computing has brought down to a lot of these regulatory requirements. We saw GDPR coming out of Europe, you need to store data in local site, sent to out of country, out of region, because of regulatory requirements. A lot of these requirements are financial, medical, government data, proprietary data, or sensitive. And then finally is visibility. You do not have connection at all, right? You can talk about a retail store, and all of a sudden connectivity is lost. You still want the retail store that functioning is so a lot of these needs are driving people to move towards edge, and people had, I mean, it's not a new concept, right? People have been doing this. But I think what's happening now is there is greater capabilities being offered at the edge, and greater number of businesses are saying that I need another important point is where is edge located? So edge, there's no single edge. I think the idea here is that there are different tiers of edge. So for example, starting from the right hand side, and that's core of this circle or onion diagram is the center. As you roll out towards left, for telecommunication service providers, their edge is instead of my core data center in 500 region, right? Or in a city in Boston, that's a edge for them. But it could be a radio hub, right? So we can talk about one example here. Ours being located everywhere, that's the last mile access for them. That's what they consider the far end. For enterprise customers, their edge starts with factory or office or retail store, right? So the definition of edge changes on what kind of business you are. And then on the extreme left is devices or sensors that can be spread all over. And just to make a point here, a lot of examples we see are for or could be for our cell phones or smart watches or sprinkler systems, which are located to the edge, but they are more focused on the consumer side. Like this presentation, we are going to focus on the business side, not on the consumer side. Just right? Yeah, so some of the examples for edge, we talked about edge being different for different industries. Here you see that, like, this is not something that is going to happen. Telecommunication providers talk about the Verizon, the AT&Ts. They have been doing edge computing for years. Now they are accelerating by doing some of the things we talked about. We had a talk on Thursday. They talked about how our telco vendors adopting this. They are doing it 5G. They are doing it with radio access networks. They are doing it on their business support system, operational support system, to support 5G. It's happening on the industrial field, but it's manufacturing. So they could be talking about, okay, how do I do predictive maintenance so that instead of machine running out, and then my assembly line stopping out, and I figure out something is going to happen to the machine. So I take it down to the next window of maintenance and fix it instead of this thing. Same thing on energy side, so oil and gas. There was a presentation earlier, Chad Farman talking about how oil and gas vendors it's a key, critical feature for them, whether drilling or upstream, be able to manage these edge locations, edge data, and so with that, I think what almost I think frankly talk about. So I think and I think maybe this is an important thing here to remember as we look at different use cases now, okay? They are going to be in different industries. Telecom is going to be healthcare, is going to be industrial manufacturing, oil and gas. One key thing we want to remember is that how do we, like Eric was talking about, we want to abstract out so that every implementation is not unique. We want to abstract out so the common elements go across different industries. So in this case, we're talking about common element being a standard platform that can extend irrespective of whether it's a healthcare or a telecom. So the idea here is very similar to I think Red Hat like then it's a hybrid cloud, right? Instead of hybrid cloud being just data center and your location, on-premise location, we talk about that this would be a oil rig, right? It's a location where you able to manage it the same way you will manage it. Instead of having totally different scheme of like expertise or tooling to manage this. So I think we are talking about footprint, it could be infrastructure, it could be virtual platform, it could be internet platform, it could be natively on hardware, but we want similar way of managing. Now we're going to talk about actual examples. And we're going to use the same template that Eric talked about, starting with the architecture slide, which is very high level view. We don't this. So here we are talking, this is an example of a customer who is one of the biggest gas suppliers in Europe. Southern Europe. So they have gas pipelines that bring in gas from these stations or from storage terminals and they distribute it throughout their customer base. One of the things for them was they had been monitoring these gas pipelines, but the data wasn't real time. They had their own operations, ways of doing things that were inefficient. And they wanted to bring us like the same thing they were doing in data center like microservices architecture, real-time, speed-based, event-driven automation. They want to bring the same capability to the edge. So what they did in this was they deployed, these edge. Well, they were still running OpenShift. This was more of edge location, but still using it, right? So this was either a single cluster or single OpenShift or edge location. And they were running their microservices, deploying the clusters the same way they're doing on the other side. That was an example. They were able to manage this with data, and one of their things was if needs for energy, like smart energy grid, their demand is going up, I should be able to control the supply of this from where the supply is being produced, right? And if the demand is going down, I should be quickly able to change my supply based on the demand. That was, and I'll just show you the next slide based on a little bit. This is what virtual diagram that Eric talked about. So on the right, you have your centralized side. This would be your data center on-premise. This would be a public cloud location, which they have. So they have spread across. And all of this is running on a common virtualization platform, right? Here, and they are running on a hybrid cloud.
Funny story behind this. What you're looking at here is a very simple thing showing an image representing very common organizations, structures. These pieces of text here, that's something that got added about a year in. I was talking to a customer and showing him something that used to stuff. He said, this is literally his words. He said, my architects aren't smart enough to figure out what you mean. So a little bit of text in here. So, fair enough. Feedback. Let's fix that. Okay.
All right, so let me jump to the next example. This one is industry edge. I think if you're in audience and chat room, earlier they talked about very different. This is the same kind of idea. This is an exact application of what is. So here we have factory side, which is doing a lot of local processing of data. We have local dashboard that shows what's happening on the factory floor. They have an AI/ML application that is able to look for anomalies in the production data. So if anything comes up, the alert goes on the dashboard, and if they are configured, they can send the alert to the supervisor or something. If something happens, they look. And then they have the data actually coming from the line data servers or sensors on the assembly floor. Data is coming in, and the data is sent back to the sensor side for model processing, model development, document storage. And obviously, you can see what they're trying to drive with this. Obviously, provide data, real-time insights into this data, reduce costs. Do it in an automated manner. We talked about the integrated state and of doing this. If there's any update to the application on the centralized side, or if there's an update to the AI/ML model on the centralized side, without any intervention, this will be pushed down to the edge side. This is the further breakdown logical, right? You have on the left the factory, and the factory is not a typical edge location. I mean, you still have a factory data center. It could be just a cluster stuck in a cloud somewhere. Right? It's fairly beefy. It's not something that you find on the bin. It's still beefy structure data for this. So you have live data server that's connected to sensors. You have firewall to protect the data, operation data from resident. We have the resident component logic to the server for dashboard. We have data from the edge devices. You have the input screen, taking this data, mirroring it back to something like we have the anomaly running in the board, which is the interesting framework or the application this side. And then on the centralized side, you have all the long-term storage, data modeling, some of the components that to this
So when you see this, you think, oh my, what am I going to do with this? Everything he's talking about has been documented in the materials behind this use case. So if you go to the Red Hat Architectural Center, we have defined each one of these things published. redhat.com/.
And actually there is, so if you are interested in, okay, this is how you operate, how what's actually happening on the ground, how is data coming in. So again, there's many diagrams that put in the graph. So it's showing that the data is coming in, and there are a couple of those, right? Data is coming in from the sensor, how is it being streamed from the edge side to the sensor side, right? So actually many diagrams put in the graph. Another workflow is model is being updated, how does it get pushed to the repository and then to containerize imagery repository and then all the rest. So it shows the actual interaction. Yeah, so when you go to that second, even towards the end of the back of the data, you find out more on the this one is medical diagnosis, what we have been edited. So same idea, right? So you have image processing happening on the edge side. So in this case, it's a hospital. So you are taking X-ray, and then you are traditional model is you're sending this X-rays to the expert somewhere, and then diagnosis comes in. Then you do the next thing. Okay, schedule, you get it on, and you talk about thousands of these X-rays being taken. There's time lapse. See when the results come in to the actual doctor telling the patient, hey, this is the diagnosis.
And the use case behind this was pneumonia detection, so lung photos. And I found another one where they were doing brain scans. The whole idea is to automate it enough that you're getting a higher percentage of automated
Same idea, actually using AI analysis case. I know that if the X-ray is like this for the lungs, there's a 90% chance that there is some possibility of let's schedule this, right? So the doctor we actually talk to the patient while right after the X-ray. Right? So bringing people to the edge allows them to do things in real time, using some of the technology that happen to other places. All right, so this is the logical view. Edge services we offer, and then there's the diagnostic facility, like care center. Model and storage of data.
Think about it, this is where your developers are sitting, actual centralized healthcare developers that are making the apps, the things you're using for this stuff. Here's a centralized area where medical staff complicates. This is where the actual compute power. These are satellites.
So you probably noticed that all of these, right? I mean, we've talked three so far. Very common way of doing things. You have your centralized side that has common elements. Then you have your edge side that are using of these same infrastructure elements. Edge. It's just that what kind of data you're processing, what kind of application you're running, varies from whether what application it is. But overall architecture is very similar. The fourth one is a little different. This is the one we talked about for medical systems, right? So when you have a cell phone and you try to make calls or look for something on your web browser, it's connecting basically the modem in your cell phone is connecting to the access tower. Then basically saying, okay, what do we do with this? Is it a customer or not? The number of things happen, right? Like customer, then they have actually account balance, the prepaid, postpaid, what kind of interaction is it, and then it sends to the next hop where all the data is, right? So what has been happening for telecom service provider is that these are very, I mean, we're talking about tens of thousands of dollars right long. Right? It's very expensive to maintain. They are an upgrade happening every couple of years as we move from 2G, 3G, 4G, 5G now. And this is bulk of the expense, right? We're talking about, for example, capital expenditure wise, like $20 million and for Verizon a year, right? And operational expenditure that you maintain this is close to $1 billion for all the deployments. Right? So this is like 65% of the gross margin spent on doing this. Just the revenue.
I think it's fascinating to see you guys really trying to test it. Test it.
And it's traditionally very expensive for them, while they are able to get value from these services. You pay AT&T whatever per month, and you are running a lot of applications, WhatsApp and Facebook are actually monetizing from these. Right? So network wants to offer you services 5G, they want to monetize it, they want to move faster. And one way of doing that is instead of buying proprietary boxes of Ericsson and Alcatel, and they want to break apart, disaggregate it. But in the same way, I mean, off-the-shelf server, you have a layer of abstraction of software, and then software applications running off in different network functions, or whether unit, radio unit in this case, right? So all these capabilities running in software is not running in hardware. That's what this one is showing that, what telco service products they want to break down these capabilities, not having this big one box offering the service, radio part, right? So radio unit is kind of broken into distributed unit and control unit, and then radio unit is just being offered some power, but then you aggregate of this capability as you go through. And it allows them to be cost effective, agile, offer different kinds of services. Like if somebody wants VPN connection to all their cell phone devices, they may want to say, okay, this is the subscriber that I'm going to offer all this traffic. Another example could be if you are in stadiums, right? And there's a big game on a Sunday evening, then that 50,000 consumers will show up, demand is peak, and then 3 hours later demand is down to normal. So how do I serve these 50,000 customers just for 3 hours without installing a lot of infrastructure? Some of the things you do is that you have multiple components that you are, for that 3 hours, you are offering just cell connectivity fees. When that goes away, these other software pieces are not that, not just connection part. This is the breakdown of what we talked about.
Also, before you get any ideas, building this out.
Yeah. So we talked about disaggregating the radio network by splitting the radio effect unit, radio unit distributed in centralized unit. So we can spread across. So for them, they have four data centers, they have three data centers, they have a data center that is gated. In this case, what was in financial district, right? Cell side, which is actual power, which is located. So they are disaggregating components, and part of this is software. In this case, we are talking about this containerized application. And for network service providers like Verizon is a good example there, they have been trying to do this. Right? They moved from just running on hardware to running on virtualized. They did that, and still they were not able to do this in outsourcing. Still takes them our hyperscalers. They decided to containers, and that's what's happening with our same thing, same way of provisioning these, same way of deploying applications as their peers competitors. That is the last one. So I have a couple of minutes of, interaction between all of these components, the backup to the site that.
Yeah, they're live right now. Type. Questions? Schedule this for an hour. It's better.
How do you handle air gap installation?
Yeah, so, and that is a very typical scenario, right? You have a factory, your operations manager for that factory, your biggest concern is this factory. Right? I cannot have anything stop my assembly line, right? So they have a lot of these requirements that we have, not in essentially like we have a maintenance window that is 3 hours on a Sunday night, right? And any changes, any thing you complete has to happen. So, and that's why the OT, the operational technology people, never work with IT, because they're saying, you guys break things, you don't care if the server is down, but we care because the factory is down in 3 hours, that's the big deal. So now what's happened is, yes, that's been great for data department, but the technology, how they manage it, it's not very quick. If they need to, it's not code, right? So if they need to change what they're manufacturing, if they figure essentially, they are not on they're not in the list of projects, right? So they might do it, right? Instead of it running on hardware platform, we need to configure software that is agile, updatable, but then the risk of how do I make sure that it doesn't break the IT thing, right? So that air gap environment is a good thing where they get less purpose, they can have their, more data technology, but still disconnected or connected to their equipment, right? So they say, okay, the assembly floor is going to be down for maintenance. That's how. But again, with the expectation is different, right? Bosch factory, like a couple of years ago, we were trying this. At that time, what we call, they download all the artifacts, everything from that, and okay, that's fine. Like, we actually have to figure out, go to IT, the information. Yeah, so it is a big deal. We need a different way of figuring out than what we did.
Any else?